First, some introductions. I don't think I've ever spoken in front of this group before. My name is Ron Pontes. I'm the manager of environmental decommissioning strategy at SONGS. Been working closely with a team of specialists over the past 3 years to work with the state agencies, California State Lands Commission and the Coastal Commission, to get the necessary permits that we need to start the dismantlement of the plant. My work in the nuclear power industry goes back to 1975. I started in this industry as a nuclear power plant operator with the Navy, and since then I've focused my attention, or my career has been focused in operations, maintenance, engineering, and project management. And now here at SONGS on environmental. I will tell you, you heard it from Lou, about what our priorities are. Our core value at SONGS, my core value and the core value of my colleagues, is safety. We have an obligation to carry out our work safely and to protect our workers, the public, and the environment. You have my commitment and the commitment of my colleagues to do that. So now we'll get into the presentation. If we can go to the next slide, please. Okay, I mentioned over the last 3 years we've been working on the necessary documents and approvals to start the decommissioning. Earlier this year in March, the California State Lands Commission certified the environmental impact report that they had developed over the past couple of years, and they approved the lease for the offshore facilities. That EIR looked at the entire project. Based on that EIR, we filed an application for the onshore work for dismantlement of the buildings on site. That CDP was approved in October 17th of this year down in San Diego, in Chula Vista actually. Now that we have that, we're working through the mitigation monitoring program and the special conditions that exist inside the CDP to meet those requirements so that we can start work. Looks like we're probably be in a position to have those mitigation monitoring requirements and special conditions satisfied middle of December, early January. Depends on how things go with the agencies. Let's go to the next slide. So now I want to talk about two things here that are coming up in this discussion. One is the dry cask storage system radiation monitoring system. And the other one is I'm going to talk about the releases that we're going to make starting a little bit later this year or early next year. So this system that you see up here on this screen, we really owe attention to Mr. Gene Stone. I think he was a former member of this panel, and Gene worked real hard to persuade us to install such a system. He made a number of visits to the site, bringing his own monitors, and we allowed him on site. We helped him take the measurements that he wanted to take, and we had a number of discussions with Gene about the system that he proposed. So well done, Gene. Thank you.
And he's in the audience, and he'll be signing monitors during the break.
Okay. So about this system, we went back, took his input, we designed a system, we procured a system, and we've installed it. It's presently being tested, and we would expect to have this system in service early in January. Okay? Now, the way it's going to work, it will stream data real time to the California Department of Public Health Radiologic Health Branch, and that department will publish monthly reports that have the high, the low, and the average readings off of each of the detectors that we have installed around the ISFAC, around the dry storage facility. We have 3 detectors installed in that area. They're capable of monitoring radiation levels at a very, very low level, micro rem, and all the way up to 10 rem per hour. So I can tell you that the radiation readings that they're gathering today, based on our test results, range between about 10 to 13 millirem at the lowest, up to about 10 to 13 microrem, up to a high of about 20 microrem at the highest. And that's compared to a background radiation reading at our control point of about 10 millirem. So I think we would all agree that the radiation levels there at the ISFAC are very, very low. Excuse me, I said it again. I meant microrem. Excuse me. Thank you, Lou. Okay, so like I said, we're still testing the system. We expect to have it in service by January, and it's one of the prerequisites before we start dismantlement. Okay? So the next subject, you can go to the next slide, please. So a little bit of history about liquid batch radiological releases. This was a point of discussion between myself and my other colleagues with Surfrider Foundation. Surfrider encouraged us to take a different approach to how we make these releases in terms of notifying the public. So here I'm going to review a little bit about what the history has been. So we've been making these batch releases since we started the operation of Unit 1. So Unit 1 started nuclear operations, critical operations, back in 1967. So we've been making such releases like these since that time. We've continued to do so until recently. I think the last batch radiological release we made was in 2016. So we're about to start that again. These releases are performed in accordance with our NRC license, and I can tell you that they are very, very low levels of release to the environment. They're all monitored, measured, and we report them annually in our effluent reports, which go to the NRC, and those same reports can be found on the songscommunity.com website. Okay. Next slide, please. So one thing to note is in the past, we did not report to the public these releases before we made them. We simply made the releases, we made sure we were compliant with the requirements before we made them, and then we reported what the releases were to the NRC in our annual effluent report, as I said before. Now going forward, we're going to operate differently. Going forward, we're going to notify the public 48 hours in advance prior to making these releases. We're going to report them, and we're going to characterize the estimated volume, the estimated duration, and the radiological characterization of these releases. So that's our plan. This information will be posted on the songscommunity.com website. It'll be available for members of the public to look at it and understand what our plans are. Next slide.
Can we just, while we're on releases,
Yeah,
Dan,
sure.
is it on this theme?
Ron, real quickly, could you review for us what the discharges are composed of? Because it's our understanding you're no longer bringing water in for cooling. Is this salt water that is, or what exactly are these discharges?
We have today we have an inventory of around 300,000 gallons of fluids. A lot of those fluids have been collected from condensate from HVAC systems. And some of these fluids were inside the plant when we shut down. Were in sumps and other tanks. So these fluids are the ones that we're going to release. They're not salt water. They started out as very pure demineralized water and were used for reactor operations typically. That's where they originated. Okay.
So when you say in your remarks that it's going to be, I think, quote, very, very low, when the radiological characterization that will be part of the public notice will tell us what very, very low means?
Yes.
Okay.
We'll likely characterize this in terms of millirem dose to a person. Okay, so a member of the public is allowed to get up to 25 millirem total dose from all sources from our plant annually. Typically that dose is down around the 1 to 2 millirem range in total on an annual basis. And the contribution from this is much, much smaller. It's a fraction of a millirem.
And that's estimated by knowing the characterizing the release and then how it diffuses through the discharge pipes, which
Correct.
will show us in a moment.
How it's diluted. So we have water, we process it, we clean it up before we release it. That's a very important point. Process it through a demineralizer. Then we sample it. Then we analyze the sample, and the sample is used to calculate the dose, what's based on what's in the liquid.
And we should let you go on, but just one last question, which is, would this be then the only plant in the nation that actually notifies the public prior to release?
It's the only nuclear plant I'm aware of that's making advanced notifications. I'm not aware of any others.
Ted Quinn on this?
Yeah, when you do the notification, do you also put the NRC acceptance criteria limits out so that we show that it's 1/100? Do you do that?
We intend to do that, yes.
Okay.
Mm-hmm.
Anything else?
Will there be continued production of more of this radiological material, or is this just the stockpile that you have to get rid of?
Okay, so I mentioned that we have about 300,000 gallons of fluids and tanks that we're going to release. That's in the near term. We also have about 1 million gallons of water that exist in the spent fuel pools today. that water needs to be cleaned up and eventually released too after the fuel's been removed from the pools. And then finally, there'll be water used for the cut-up of the segmentation of the reactor vessel internals, and that water will have to be cleaned up and released as well. So we would expect, based on our current projections, that sometime in year 2022, if we follow the schedule that we anticipate, that we would be finished with these releases. At that time, we would stop the releases, we'd close the conduits, and there would be no more of these releases. Okay?
Anything else? It'd be great to know sometime how many releases you expect between now and 2022.
Yeah, we can predict that, I think.
Okay, we should let you go on.
Yeah. Next slide. Okay, so as part of this, we'll characterize the releases that we're making. I also want to remind everybody that we monitor the environment to measure the impact that the plant is having on the environment. So we take ocean water samples, soil samples, kelp samples, beach sand sediment, fish species, crustaceans, and so on. And we measure each of these parameters for radiation. This is done on different frequencies depending on which thing you're talking about here, which parameter. And all of this stuff is gathered, collected, and put into our annual radiological environmental monitoring reports, also given to the NRC and also available on our website. Now, we are going to do something a little bit different here too. We're going to start reporting these parameters that you see here on this slide more often and on our website, and in a way that's easy for members of the public to understand the information that we're putting out. So we're going to start doing that the first quarter of next year. Okay?
Gary? Hold on a second.
Yeah,
A question here.
I just have a question on the batch releases. You just made the comment when we drain the pool or start to drain the cooling pool, we'll clean it up. I would like to, at some point, have a more thorough description of how you're going to clean it up. If you're bringing in a filtration system, and what is that going to look like?
Yeah, Gary, we'd be glad to do that. Just generally speaking, for now, we process the water through ion exchangers. Those ion exchangers reduce the contamination levels inside the liquid to very low levels, and then we release the water. The ion exchangers media that takes up the contamination, when it becomes exhausted, they're shipped off-site and usually going to Clive, Utah for disposal. Okay? But we can come back and give you a more detailed description if you
That'd
like.
be great. That's very helpful. Jerry Kern?
Just, so how much volume over what period of time is a release?
Okay, so these releases that are coming up that I'm talking about right now, they're roughly about 20,000 gallons apiece. The release period would be 4 to 8 hours in that time range. And we'd be planning to do these, first quarter of next year, or maybe the first one here in December. Okay?
Okay, thanks.
Next slide. Okay, so here, this is a diagram showing the plant site on the right, showing the conduits, and you can see there on the left, about 6,000 feet offshore is where the discharges actually emanate into the ocean. So it's more than a mile offshore where this highly diluted fluid is processed into the ocean. So to give you some sense of where this is happening at.
And it would be done entirely through the Unit 2 conduits?
Correct.
Okay.
That's right, David. Any other questions on
No,
this?
should let you continue.
Right.
Ted Quinn?
Yeah, I have a question on the permitting through the Navy. Your first slide was on permitting.
Yes.
Is this the right time to ask a question on permitting with the Navy? Are we done? Or is there still work to be done?
No. So the permitting that I talked about previously is the permitting necessary to remove all the above-grade structures onshore and disposition the offshore conduits. Okay. The later stages, the site restoration phase that will follow, is after all the fuel has been removed from the site. So at that point, or when we know that we're confident that the fuel will be removed from the site, then we'll enter into a discussion with the Navy about what the end state will look like, and that will be a combination of the Navy and the Coastal Commission.
Okay, thank you. Is this your last slide?
I think so. Yeah. Any other questions or
Anything
comments?
else? I think it's been very informative. I think we've got some more things to learn about, but I appreciate your presentation.